In this particular video, we will finish up the fourth section of Chapter 3. We have looked at a variety of properties or laws of logarithms to help us to evaluate logarithms and to rewrite logarithms into special forms. But what we need to do is we need to consider what happens when we have a base for a logarithm that is something that we can't compute because we don't have that key on a calculator. We have common logs base 10, we have natural logs base e. But for example, we don't have a base 6 logarithm. There are no tables to my knowledge of base 6 logarithms like we used to use the tables back in the old day, although I'm sure that they probably exist somewhere. So what we need instead is what we call the change of base formula. And the change of base formula, what it does is it allows us to rewrite a logarithm that has a base that we don't have the ability to approximate into a logarithm or a logarithmic expression that involves a logarithm base that we do have the ability, like a common log or a natural log. So in this case, let a and b be positive real numbers such that a, remember this means such that a does not equal 1 and b does not equal 1. Then for any positive real number x, the log base b of x is equal to the log base a of x all over the log base a of b. See how I went from base b to this expression here that has two base a logarithms. And base A could be 10 or it could be E. It could be 10 or it could be E, so we can figure that out on the calculator. So one way to remember which one gets which is that if you look on the left side, the B is a little bit further down, the X is a little bit further up, the X goes on top, the B goes on the bottom. That's the way I always try to keep track of it. Now I can't approximate a base 6 logarithm. I mean, I can get it between a couple of integers anyway, because I know, for example, this one, the log base 6 of 6 is 1, and the log base 6 of 36, which is 6 squared, is 2. And since 23 is between 6 and 26, the log base 6 of 23 should be between 1 and 2. But that's not a very good approximation, so let's see if we can get a little bit better one by using the change of base formula. Use the change of base formula to evaluate the log base 6 of 23 by using a base 10 logarithm, a common logarithm. So I'm going to write that the log base 6 of 23 is equal to the log base 10 of 23 divided by the log base 10 of 6. Now if I get my calculator out, what I can do is I can figure out what these expressions are equal to. The top one is equal to approximately 1.361728. The denominator, the log base 10 of 6, is approximately 0.778151. And then if I go ahead and take this a little bit further, and I'm going to round to 4 decimal places, I end up with 1.7500. So it's pretty close to 1.75. It wouldn't be exactly that, and that would be my approximation, and that is between 1 and 2. So that's at least a proper looking answer. Now let's see if we can do the same thing over here, the same exact logarithm, but this time we're going to use base e, which is what I prefer anyway. If I'm going to do this problem, I'm not going to use common logs, I'm going to use natural logs. Students sometimes wonder why. It should work out the same way. What's the difference between a common and a natural log? Both keys are on the calculator. It's just that it's less writing. I save a whole letter here. So this is the natural log of 23 divided by the natural log of 6, which should be approximately here, the natural log of 23, about 1.36, 1728. The natural log of 6 being approximately 0.778. Oh, no, I got this. I think I'm doing the same thing that I just did. I am. Heavens to Murgatroyd. I'm doing the common log one because I'm not paying good enough attention here. Let's try this one again. The natural log of 23 is about 3.13. It couldn't dare be the same numbers there. 5494. And the natural log of 6 being approximately 1.79. 1759. All right, here we go. Yeah, I don't have these memorized. I'm looking off of a piece of paper that I have, but I was looking at the wrong example. Now this, as it turns out, when you simplify this to 4 decimal places, is 1.7500, the same exact approximation. And that should make sense because I can do this for any base logarithm as long as my base is not equal to 1 and it's a positive real number. Now it says check your result by using the related exponential form. Well, what they mean by that is when they ask you log base 6 of 23 is what, they mean 6 to what power is 23. I'm saying 6 to the 1.7500 power better be 23. Well, if you get Mr. Calculator out, you get 23.00195. And that is pretty close to 23. It's not exact, as this is not an exact answer, this is just an approximation. So this ends up close, as you can see, 0.00195 off of being exact.